All right, let's have a refresher of the transformations that we either talked about today or yesterday. Okay. What I'm trying to get you to understand is what the parent form of a quadratic looks like. So every quadratic we talk about originates with the parent. So we have a parent, okay, and that parent is y equals x squared. Okay. Everything we talk about with quadratics originates with this parent function. Okay. We can make a t-table, we can make an xy chart for this parent function. So I'm going to do it on the side here, kind of small. Right? So, and I'm going to pick points. I'm just picking points at random. So I'm going to start with -5, -4, -3, -2, -1. We're just going to do a whole bunch to try and prove a point here. Okay. If these are x values, I am allowed to substitute x values in for x values. So what this would be saying is what's -5 squared? That's 25. What's -4 squared? 16. And I can keep this pattern going. The cool thing about a quadratic function is I'm going to get a mirror image. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Okay. I'm now going to take the time to plot these points. These are all points. -5, 25, -4, 16. Okay. I'm going to start in the middle, and I'm going to plot 0, 0. So down here at the bottom, you can't see it because it's too dark, but there's 0, 0. Then I'm going to plot 1, 1, -1, 1. Okay. Then I'm going to go to 2. 2 is equal to 4. And -2 is equal to 4. So I've plotted those points. Okay. Then 3. 3 was equal to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's -3, 9. Okay, they're mirror images. This is going to be a symmetric graph. 4, 1, 2, 3, 4 was at 16. So that's 9, 10, 11, 12, 13, 14, 15, 16. And there's a point right there. 5, 25 isn't going to fit on our graph, so we're going to use arrows to demonstrate that this goes on forever. So I'm going to put arrows here. And I'm going to graph this just like this. It's going to go up, and then I'm going to curve it to come back up this way. This is a quadratic function. The graph is called a parabola. Okay? We can make transformations. We can change this graph however we want, but it's always going to start with x squared. So I want to redo your notes and show you what I mean by these transformations. Okay? So what I've done is I've taken a transparency, it's a nice little clear sheet here, and I've traced my parent function. Okay, my parent function is traced there. So we're going to use this as an example here momentarily. Your packet of notes should be out, and we should be looking at this first part here. Okay. When we graph, for starters, or when we talk about transformations, we're going to talk about it in this vertex form. Okay, we got to talk about it in this vertex form. Okay. The first transformation that we're going to talk about is a vertical shift. Okay, we want to move something up or down. Okay, so I have some of these filled out already, so let's look at it. Okay, so when I have a vertical shift, okay, that's affecting my y values, and it's the k value of this equation. Okay, if I have a positive k, I'm moving up. If I have a negative k value, that's telling me to move down. So let's look at this on a graph. So here's my quadratic. If I told you I wanted to move this thing up 2, we would go up 1, 2. So what my hope is that you can see, here's where we started, And the dark blue line is what changed. That's what the transformation is. We took our parent function x squared and we moved it up 2. So if I were to write this equation, okay, we started with our parent function, y equals x squared, and I then told you to move it up 2. That 2 tells me to go up 2. Okay. So let's go back to the beginning here. Okay. If I said I wanted to move this parent function down 6, okay, I'll move this up, then I'm going to move this thing down 1, 2, 3, 4, 5, 6. Okay. So again, this is where we started. Everything starts with the parent. This is what has changed. So if we start with our parent function here, and we say y equals x squared, okay, that was our parent, but we moved this down 6. So we'll represent that with a minus 6. All right. Let's talk about a horizontal shift now. Okay. When I look at my vertex equation, okay, my horizontal shift is the h value. Horizontal is going to affect x values, and it's a plus or minus h. But remember, anytime something is by the x with quadratics, we're always going to think the opposite. Okay, we're always going to do the opposite. So this should be a always do the opposite. Okay, so if I have a positive h, I'm really going to the left. And if I have a negative h, I'm really going to the right. So let's demonstrate this left and rightwards movement. So pick this up. Okay. Let's bring our quadratic back to the origin, back to the parent. If I go left 5, I'm going to say this is going over 1, 2, 3, 4, 5. Okay. You should be able to see with your eyes that this quadratic function here moves over 5. Okay, it moved over to the left. So what if I wanted to represent that with an equation? Okay, so remember our vertex form equation is y equals, well, a, times x minus h squared plus k. That has a minus sign in it. Okay, that'll always have a minus sign. So this is really x minus something squared. So if I tell you to head to the left, that value is really what? This value right here is really a negative 1, 2, 3, 4, 5. Well, what is minus a negative? It's a positive, so this is really x plus 5 squared. That's why we do the opposite. Okay? That's the best explanation on why we do the opposite. So what if I ask you to go to the right? So let's go back to our parent function here. Okay. Let's go back to the parent function here. Okay. Let's go to the right 3. So I'm going to pick my graph up and I'm going to head towards my right hand. 1, 2, 3. Okay. So if I want to write an equation for this, okay, remember that my template is x minus something. How many spaces did I tell you to go right? 3. So you just put in a 3. That's why it looks opposite. That's telling me to go to the right 3. Okay? Let's talk about a reflection now. A reflection is when your A value is negative. It's not the A value, there's just a negative out front. Okay? This reflection affects the Y values. Okay? It'll always be represented by a negative out in the front of my equation. And it tells me to flip my graph over the x-axis. It's going to tell me to flip my graph over the x-axis. So let's make a visual of what this looks like. Okay? So here's my parent function. If I tell you to reflect it, it's now going to look like this. Okay? It's upside down. So we started with our parent function of y equals x squared. That's this parent right here. And when I reflect it, I'm just going to put a negative out there. It's telling me to take all of my answers and make them negative. Okay? So I'm just flipping that over. So let's look at a couple examples of how to identify these transformations. There is a +7 out back. Okay. So if I were to write this in vertex form, if I were to change this up a bit, this would be x minus 0 squared plus 7. That's telling me to take my parent function and move it up 1, 2, 3, 4, 5, 6, 7. What is the ordered pair for that point? It's at 0, 7. Okay? So my graph is moving up 7. Okay. There's a couple things going on here. There's one thing, there's two things, there's three. That negative is out front. That tells me to reflect. I've reflected my image. So that negative means to reflect. If I want to do +5, that's really telling me to go left. Remember, you're always doing the opposite with something next to x. So we reflected it. Now let's go left 5. 1, 2, 3, 4, 5. Okay? So I've done two transformations. That -2 at the very back tells me to go up or down, and since it's minus, it's telling me to go down 2. So looking at our graph here, we're going to go down 2. So there's where we started. There's where we always start. Here's what the transformations look like. Okay? Now, the one thing that I did not review, okay, and I'll do it now since we've come across this variable here, or this fraction, is if we have a stretch or a shrink. Okay? If you have a vertical stretch or shrink, that's affecting the y values. Okay? Your vertical stretch or shrink is represented by the A. Okay, so remember the negative is only reflection. This A value tells me if I have a stretch or a shrink. If A is bigger than 1, I'm going to get something really tall and skinny. That's a stretch. If A represents a fraction, which means A is bigger than 0 but smaller than 1, I have a shrink. So if we look at this third example here, 1/2 is smaller than 1. This is a shrink. That 10 is by the x, so it's telling me to go left or right. If I think of the opposite, it's telling me to go right 10. We will continue talking about transformations. I just need you to be able to identify them so we can move on and other ways to